Hi, it's Professor Monty again. Let's learn how to solve inequalities algebraically. All right, so the key when we do this is remember when solving inequalities algebraically, only flip over the inequality when you multiply both sides of the inequality or divide both sides of the inequality by a negative number. So if we multiply by a negative number or if we divide by a negative number, flip the inequality to face the other direction. Any other operation, we don't flip, we just leave it the way it is. Okay, so let's look at some examples so we can get this down. We want to solve this inequality. So obviously, just like solving an equation, we want to get the x by itself. So I'm going to subtract 2. Notice I leave the inequality just the way it's pointing. Divide by 3. I still, since I'm dividing by a positive number, I don't flip the inequality. And I get x is less than negative 10/3. That's my answer. So if I were to graph this, parentheses, because there's no equal, I don't include the negative 10/3, but it's less than that, so it's to the left of. It's everything over here at negative 10/3. So we can use that as our answer. If they want interval notation, we need to draw a picture of this or state in intervals what this is. Well, it's going to the left forever, negative infinity, and it's going to the right until we get to negative 10/3. Doesn't include 10/3, so that would be my answer in interval notation. All right, a couple more. Now I've got a fraction that I'm starting off with. Well, notice I want to get rid of this 4. Let's get rid of the fraction first. I'm going to multiply both sides by 4. That's going to cancel this, but I'm multiplying again by a positive number. Don't flip the inequality. So I get 5 minus 2x less than or equal to 40. Subtract the 5. Negative 2x, did I say greater than or equal to? Greater than or equal to 35. Now when I divide, though, I'm dividing both sides by a negative. Now I have to flip the inequality. So it's x instead of greater than or equal to, it's less than or equal to. Negative 35 halves. Again, if I were to graph that, it's going to the left again. This time it has an equal, so I use a bracket. Way back when we were doing inequalities, we may have used an open circle and a closed circle. That's the same idea as the parentheses, the open circle, brackets, the closed circle. The difference is these lead right into how I'm going to write my interval notation. So this is typically the preferred way to do it now. And again, this is going always go left to right, negative infinity. And remember, since infinity is not a number that we attain, there's always parentheses at negative or positive infinity to negative 35 halves, bracket on that one to say, hey, I include that value and don't go any further than that. So again, in inequality notation, interval notation. And then lastly, I want to get rid of the fraction. I'm going to multiply by negative 3. This time I'm multiplying by a negative, so this time I will flip the inequality. Greater than or equal to negative 15. And then add the 6. When I add or subtract or multiply or divide by a positive number, I don't flip the inequality. X is greater than or equal to, what is that, negative 9? So again, graphically, this time it's going to the right. It's greater than or equal to the negative 9. It's going that way. And so my interval notation is going to be negative 9 with the bracket all the way to infinity with the parenthesis. Interval notation. And then that's just inequality notation. Okay, so I hope that helps out. Work with these, practice. I didn't list all the different rules because most of them say, hey, don't flip the inequality. The only ones that say flip the inequality, if I multiply both sides by a negative number or divide both sides by a negative number, then I have to flip the inequality.